Well, hello, good people. Today, we are going to continue our conversations about color mixing. We talked in our last video about color addition, and today we're going to talk about color subtraction. Now, color addition happens when we're adding together different frequencies of light, like adding together red light and green light, or adding together red light and blue light, or blue light and green light, and those kinds of things. Color subtraction happens when we're adding together pigment or dyes or ink. So when you think about mixing paint, what you're doing is what we call color subtraction. You're mixing different pigments. Or if you're mixing dye or mixing any kind of ink, all of that is color subtraction. Now, when we talked last time about color addition, we said that there are three primary colors of light, and those three primary colors of light are red and green and blue. Well, that's true for color addition, but for color subtraction, we have three different primary colors. The three colors for primary subtraction are, once again, I do not have a good magenta color here, but magenta and green. No, gosh, oh, wow, that was almost terribly embarrassing. And cyan and yellow. Those are our three primary colors for color subtraction. Now, you learned when you were learning about mixing different colors of paint in elementary school, you learned that the three primary colors were red and yellow and blue. Well, the truth is the three primary colors of color subtraction are magenta and cyan and yellow, which could very easily be misconstrued as magenta being red, which my magenta, once again, is not a very red magenta. Maybe I could blend my colors here. Does that work? Like mediumly. Anyway, this is not important. You get the idea. Your magenta could be easily misconstrued as red, cyan could be easily misconstrued as blue, and then yellow could be easily misconstrued as, well, yellow. And so a lot of times elementary school teachers will tell you that the three primary colors are red, blue, and yellow, but really deep down they're magenta, red, and cyan, or magenta, cyan, and yellow. If you went to a printer and you looked at your colored printer ink cartridges, you would see that any color printer ink cartridges, that the color cartridges have three colors. And those three colors are magenta, cyan, and yellow every single time. Every color that your printer prints is a combination of magenta, cyan, and yellow. And so we can combine colors like magenta, cyan, and yellow whenever we're painting or using ink or dyes to create any of the other colors. Now we're going to do some color subtraction kind of problems today, but before we can learn how to do color subtraction problems, we have to learn how to draw what I call a color diagram. Let's start with something like magenta. When we draw a color diagram, actually I'm going to move this up here a little bit. When we draw a color diagram, the first thing that we draw is we draw the surface that the light is going to shine down upon. Let's say that this is something like a magenta t-shirt. So here is my magenta shirt. My magenta t-shirt. Now what I'm going to draw is this is the surface of the shirt. What I'm going to draw is the incoming light rays. If this magenta shirt is in a white room, that would mean that the light coming into this magenta shirt, you would have some, let me delete this here. You would have some red light rays coming in. You would have some green light rays coming in if this is a nice white room. And you would also have some blue light rays coming in. Now, this would not be the case if we were in a room that was lit by only red light. If we were in a room that was lit by only red light, you would only have red light rays coming in. If we were in a room that was lit by yellow light, you would have red light and green light coming in. But if you're in a room that is lit by white light, you would have red light and green light and blue light come in. When these colors of light from the white lights hit the magenta, some of them will get absorbed and some of them will get reflected. We know that magenta is made up of two colors. It's made up of red and blue. So if you are looking at this shirt, here's a little viewer here. If you are looking at this shirt, that's a side view of an eye, then that means that the colors red and blue both have to make it to your eye in order to form magenta. So this magenta would reflect red and would reflect blue so that you would see this as magenta. But the color green would get absorbed. And this is how we draw a color diagram. We draw a red light getting reflected, green light getting absorbed, and blue light getting reflected for magenta. If you do not have all of these colors here available to you, then you can still draw this diagram, but what you'll do is you'll just label all of your colors like this. We'll say this one is red, you'll label it with an R. Then you'll say that the one that's getting absorbed is your green color. Go away, please. So we'll say this one is green. Then we'll say this one right here. Go away, please. So sorry, team. This one right here is your blue, like so. And there you go. That's your first color diagram. Let's draw another one for cyan. Here I have maybe a cyan t-shirt, and let's say that the cyan t-shirt is in a well-lit room with white lighting. If it's in a well-lit room with white lighting, then you're going to get all of the three primary colors of light coming in. Red light is going to come in. That red light is going to come into that cyan color t-shirt, but it's not going to reflect. It's just going to be absorbed. The next color that's going to come in is going to be green. That's our second primary color of light. That green light is going to come in, but it's going to hit that cyan t-shirt and bounce off. As you know, if you're going to see the cyan t-shirt as being cyan, then green light and blue light are both going to have to make it to your eyes. So the green light will reflect, and the blue light will also reflect and also make its way to your eyes. So you will see cyan here, the color red gets absorbed, green gets reflected, and blue gets reflected. Hey, go ahead and try on your own. Can you draw a diagram for yellow? Here's my color diagram for yellow. I say if yellow is in a white room, then red is getting reflected. Green is also getting reflected because red and green together make yellow, but the color blue would get absorbed by a yellow t-shirt. Notice once again, this is the light rays that are coming in, and this is the t-shirt that's experiencing those things. Hey, a few more to try. If you had something that was a white t-shirt, a white t-shirt in a white room would reflect all of the colors. So you would show red coming in and getting reflected, you would show green coming in and getting reflected, and you would show blue coming in and getting reflected. Blue, like this. All the colors being reflected. Last one. If you had a black t-shirt, a black t-shirt would absorb all of the colors. So red light would come in if we were in a white room, and that red light would be absorbed. The green light would also be absorbed. And finally, the blue light would be absorbed. That would mean that a viewer would see no light making it to his or her eye. There would be no red, no green, no blue. It would just appear black, which is the color of absorption and is really the color of no light. So there you go. That's how you draw a color diagram. Now let's show how you can use a color diagram to actually do a color subtraction kind of problem. Here's what we're going to do first. Let's say that I asked you if you mix magenta paint and if you mix magenta paint with, let's start with cyan paint. If you mix cyan and magenta paint, what kind of color of paint are you going to get? This is a color subtraction problem because in this problem we're mixing paint or mixing dyes. We are not mixing light. Now when we do this problem, we're going to start by drawing a color diagram, but before we do, here's the most important thing for color subtraction. When it comes to color subtraction is all about adding absorbers together. When you're doing color addition, you're adding light together. So you have yellow, or you have like red light over here and yellow light over here, or cyan light and blue light, or you're adding different kinds of light together. But in color subtraction, you're actually adding absorbers of light together. So every time you add a new color, you're adding something else that's absorbing more light. Let's start with magenta here. I start by drawing a color diagram of my magenta. My magenta, if my magenta is in white light, my magenta has red light coming in that will then get reflected. My magenta also has green light coming in. This green light, when it comes in, it will get completely absorbed. The blue light that comes in will get reflected as well. I'm going to add the magenta to my cyan. When I add magenta and cyan, cyan is also going to be in this room, and so we're going to have red light coming into cyan. That red light is going to get absorbed. the green light coming in is going to get reflected. And lastly, the blue light coming in is also going to get reflected. When we add these together, we add together absorbers. So here's what we're going to do is we're going to find out what color these make together. When we find out what color these make together, I'm going to take all of the absorbers of magenta and all of the absorbers of cyan, and if magenta absorbs a color, then our resultant color is also going to absorb that color. And if cyan absorbs a color, then our resultant color is also going to absorb that color. So we'll start here. Magenta absorbs green, so our resultant color is also going to absorb green. Cyan absorbs red, so our resultant color is also going to absorb red. But both of them reflect blue, so our resultant color is likewise going to reflect blue because there is no way that you can add a reflector of blue and a reflector of blue together and get blue absorbed. The resulting color looks something like this, red and green being absorbed, blue being reflected. If you had a little viewer right here who was looking at this situation, the little viewer would say, hey, I only see blue light making it to my eye. And so you would say this color must be blue. This is our first subtraction equation. Magenta plus cyan equals blue. Let's try another one. This time, let's see what happens if we add cyan and yellow together. If we add cyan and yellow, we want to know what color are we going to get. Well, I'm going to start with cyan. I know that cyan is a good absorber of red. Okay, so darn it, this is so annoying. Thank you for your patience. I do appreciate it. Good absorber of red. It is a good reflector of green, so the green light's going to bounce. And it's also a good reflector of blue. We know that something that is yellow colored will reflect red light, reflect green light, and absorb blue light. Our resultant color then, we're going to add together the absorbers. So if one of these things gets absorbed over here, it's going to be absorbed by our final color. Cyan absorbs red, so our final color is going to be an absorber of red. When we mix cyan paint and yellow paint together, blue or yellow absorbs blue, so our final color is also going to absorb blue. But both cyan and yellow reflect green, so our resultant color is going to reflect green. And looking at this, we have red and blue getting absorbed, but green getting reflected. Hey, this looks like the color green. And here is our second equation for color subtraction, that cyan plus yellow together equals green. Go ahead and try this third one by yourself. What's going to happen if we add together the following colors? Let's try this time yellow and magenta and see what happens. Now at this point, it's highly likely that some of you are starting to notice a trend. You're saying, Miss Wilson, I can add together the absorbers, or I could just find out what they reflect in common. You say yellow is going to reflect red and green, magenta is going to reflect red and blue. What they reflect in common is going to be red. Everything else is going to get absorbed because yellow absorbs blue, magenta absorbs green, and so our final color is going to absorb everything. Whoa, let me do these in the right order. This is kind of a nitpicky thing. You don't really have to do them in this particular order. I always do them in this particular order. I do red, then green, then blue because that goes in order from the lowest frequency to the highest frequency, and that helps me keep my colors straight. But you most certainly do not have to do that. That's just something that I do. But anyway, that aside, you could say, well, they together reflect red, so my resultant color has to reflect red. Everything else is going to get absorbed, so my resultant color is going to be red. This gives us our first three subtractions equations. Magenta plus cyan equals blue, cyan plus yellow equals green, yellow plus magenta equals red. And this gives us a whole new color wheel that we can use for color subtraction. we saw that for color addition, we had these three circles. We had like our three primary colors. Here's red. Then we had another primary color. We said here's blue. Then we had another primary color. We said this is green. And do you remember that we had this whole circle thing, and you could find like, okay, this is going to be yellow here. We got cyan right here. We got magenta right here, and in the middle we have white. This tool is very, very helpful because it lets you see all of the colors very, very easily. You can see that here you're going to have cyan if you add these two. Here you're going to have yellow if you add together red and green. Up here you're going to have magenta. And so it just very, very easy and very, very visual. You do have to memorize all of your color equations, and you do need to know them. But hey, I have a lot of students who don't even memorize the equations. Instead, they just memorize this little diagram. And they say, if I can memorize this little diagram, well then I know all of the equations. There is no equation that is outside of my reach. I know also when I memorize this little diagram what all the primary colors are. The primary colors are red, green, and blue. I also know when I memorize this little diagram, I know all of my secondary colors. My secondary colors are the ones in the little circles here, magenta, yellow, and cyan, and I know that altogether they make white if you combine all of them. Likewise, students say, when I look at this little diagram, I can see my complementary colors. I got blue across from yellow, those are complementary. I got red across from cyan, those are complementary. I got green across from magenta, those are complementary. Well, we can actually do the same thing, but with our color subtraction now. For color subtraction, we have three primary colors. Our three primary colors for color subtraction are yellow and cyan. Oh gosh, let's get a little more overlap there. Yellow and cyan and magenta. Once again, really wishing I had like an actual magenta, not just like a purple, but that's okay, you get the idea. Yellow and cyan and magenta. When we add together cyan and magenta, we found that we get blue. When we add together yellow and cyan, we found that we get green. When we add together yellow and magenta, we found that we get red. This gives us three primary colors for light subtraction, yellow, cyan, and magenta, and three secondary colors for light subtraction, red, green, and blue. Notice that the primary versus the secondary colors are exact inverses of each other here. Here's some other things. Some students will say things like, wait a second, Miss Wilson, you're saying I mix together yellow paint and magenta paint and I get red? And they feel doubtful in their hearts. They say, I don't really know that that's true, especially here because my magenta here is very purple looking because I don't really have a good magenta. They say, I don't really know that that's true, Miss Wilson. That just doesn't really sit right in my heart. Well, a lot of this, you have to hold a lot of this with open hands. When I say that we add magenta and yellow and get red, what I mean is if we added together perfect yellow and perfect magenta, we would get a perfect red if we added them in equal amounts. However, most of the paint that you experience in your life is not like a perfect magenta and a perfect yellow. If you have something, and they're not in equal amounts, if you had something that was like a little bit more magenta-y, like a little bit more, just a little bit more magenta, you'd get a little bit of a darker red. If you had a little bit more yellow, you'd get more of an orangey red. So it matters your proportions. It matters like what your magenta is made of, what your yellow is made of. So these kinds of things matter. But this is the general gist, and these are general equations that you can follow, is if you add together magenta and yellow, you will generally get red. If you add together cyan and magenta, you will generally get blue. If you add together yellow and cyan, you will generally get green. That means that these are generally the primary colors, and these are generally our secondary colors. If you add together yellow and cyan and magenta in equal amounts, the resultant color that you will get here in the center, well, you're adding together an absorber of color, another absorber of color, and another absorber of color. Your resultant color will be the color black. We use for black BK to distinguish it from blue, which is just the letter B to keep those clear. You'll notice here that this color wheel also shows us that there are complementary colors that are possible. If you add together cyan and red, for example, you will get black. Cyan is an absorber of red, and red over here is an absorber of green and blue. So if you add together cyan, which absorbs red, and red, which absorbs green and blue, well then you just added together all of the absorbers. It would look kind of something like this. Let's try it. If I add together cyan over here and red over here, the color cyan here is going to first reflect or absorb red, reflect green. Oh gosh, that is just so obnoxious. Reflect green and reflect blue. The color red, meanwhile, is going to reflect red, but absorb green and absorb blue. Hey, do you see how when I go and look at what's going to get added, I see, well, I'm adding together absorbers. I get an absorption of red from my cyan, I get an absorption of green, and an absorption of blue from my red, and so then as a result, I see that all of my colors are being absorbed, and my resultant color would be black. This is true for cyan and red. It's also true for magenta and green. Green absorbs blue and red. Magenta reflects blue and red and absorbs green. So they each absorb what the other one has, and so together they add together to make black. Same thing with blue and yellow. Yellow reflects red and green and absorbs blue. Blue absorbs green and red and reflects blue. And so put them together and you get black. These are what we call the complementary colors. You'll notice that red and cyan here are complementary colors, and red and cyan here are also complementary colors. The complementary colors for color addition and the complementary colors for color subtraction are the same complementary colors. It's just whether they're adding up to make black in the case of color subtraction or white in the case of color addition. And that is just about everything when it comes to color subtraction. With color subtraction, we see that the primary colors are magenta, yellow, and cyan. The secondary colors are green, red, and blue. When you're doing color subtraction, you are adding together absorbers of light. So you're getting less and less and less light the more paint or the more pigment or the more dye that you add together, getting closer and closer to black. We also see that there are complementary colors here that are the same as your complementary colors for your adding together light. However, they're adding together to get black instead of adding together to get white. We also see that you can use color diagrams like these ones to see what is getting absorbed and what is getting reflected in order to find out the final answer for what will be ultimately your ultimate color. And that, ladies and gentlemen, is just about all for color subtraction. I hope that you do have an absolutely wonderful rest of your day, and I will see you again in a virtual setting like this one sometime soon. Have a great rest of your day. Bye, good people.